Roman numerals, they look kind of cool. Why do we need them? No one really knows. Apparently they make a really good coding challenge. So that's good enough for me, and that's what we're going to do. This is a kind of a daunting challenge. There is a very long list of fun specs with lots of different letters it's expecting you to return. I'm going to go through this a little bit quickly. I want to try and get it done in less than 10 minutes is the goal here, as all these videos should be under 10. So for anything like this, the best thing to do when it seems very daunting is to start with a base case or like a simple case. In this case, it's going to be with the number 5 or less. Convert any Roman numeral up to the number 5. So to do that, we have to think of what are the symbols we convert with a number of 5 or less. Well, we have the symbol I, we have the symbol IV, and we have the symbol V. Technically, yes, IV is the combination of the two symbols. I think it's a little easier to think of it as its own symbol. And so it'll make a little more sense as we go along if that doesn't come completely naturally at the moment. I represents 1, IV represents 4, and V represents 5. With Roman numerals, we want the larger symbols to persist over the smaller symbols, so that if we have the number 5, we get the larger V instead of 5 ones, because that would be improper Roman numerals. Likewise, if we got 4, and here's a reason why I want this as its own symbol, if we had 4, we would want an IV instead of 4 I's, and we would want that to persist. And if we had some combination of them with like a 6, we would want the V to persist first, and then the remaining I's, or the remaining smaller numbers. So you get the idea here is that we want to start with larger values, take those corresponding symbols and bring them into our result, and then deal with what we have remaining with the rest of the number. So I'm going to declare two variables for that. I'm going to declare our result, which will be our Roman numerals, and I'm going to declare our remaining, which will start with our entire num, and as we take away numbers from that to convert it into symbols, we're going to keep track of that in what's remaining. That's a little more readable for me. You could always just stick with, the variable num. Well, it would be up here right now. You would just, stick with the variable num if you wanted to, but I'm going to rename it to remaining. So for our first case of, let's say, 5, we want to check that the number is greater than or equal to 5. So I'm going to put this in a while loop. While remaining is greater than or equal to 5, this means we want that V symbol. Basically, I'm thinking of this as a store. We have, whenever we want to take a symbol, we need to pay with its corresponding value. So if we get a 5 here, if we add 5 to our remaining, if we add our V, we need to pay 5. Or, I'm sorry, if we add that to our result, we need to pay 5. So remaining minus equals 5. You see what we're doing here is that every time we get a symbol, we want to give that corresponding amount so it lines up correctly. So in this case, with just the 5, if 5 is greater than or equal to 5, which it is, we get a V back, and then our remaining becomes 0, since 5 minus 5 is 0. Then, since it's no longer greater than or equal to 5, we can't afford another 5, it would be improper to have another V. This would just break, and then we would return, not what the remaining is, the result. I have too many R variables here. So if we converted 5 like that, we should see a V back, and that passes that. Great. So now let's look for the other spec. Let's go back down to 4 now. When we have 4, we want to compare if the remaining is greater than or equal to that. I'm using an if statement here instead of a while loop, because for a 4, I always know that it will only run once. If there was an 8, for example, we would hit this 5 first, decrement 5, and then go here, and then we would really have a 3. We wouldn't even run that at all. But this will only run once. You can make this a while loop if you want to stay consistent, if that is a little nicer for you. It virtually doesn't matter because it will only run once either way. I'm just going to use an if statement just because I like that a little more, but either way is fine. So if we have a 4, we want to add our for symbol, and we want to remove 4 from our remaining. Let's try that with 4 there. So we have that passing as well. Awesome. Now we're going to do it with same idea. If remaining is greater than or equal to 1, we will add an I, and that will cost us a 1. And let's not forget our semicolon. So for 3, for example, this runs 3 times, adds an I every time, decrements 1, goes from 3 to 2 to 1 to 0. We get 3 each time. So this is great. We're starting to pass, and we're kind of getting a structure of how we can approach the rest of this problem, which at first seemed overwhelming. Now it seems a little more manageable. The next symbol is our x, or 10. So we will just, while that is greater than or equal to 10, result plus equals x, remaining minus equals 10. Below that we have our case for the number 9, which would only happen once, if at all. So if remaining is greater than or equal to 9, result plus equals ix, remaining minus equals 9. Let's run another test, see how we're doing. Looks like more things are passing, and we are right up to where we want to be. So we will go again with 40 and 50. I'm just starting at 50 while remaining is greater than or equal to 50. Result plus equals, what is the symbol for that? Have it on another chart here. Result plus equals L. And remaining minus equals 50. Underneath that, and I'll do it with an if to be consistent in how I am coding. Remaining, if remaining is greater than or equal to 40, result plus equals XL, and remaining minus equals 40. Great, and I forgot a semicolon there. Let's run another test, make sure everything is correct. Looks like we are pretty much up to where we need to be. Yep, this next one is with a C, which I haven't coded for yet, so we don't expect that to pass. So while remaining is greater than or equal to 100, we will have result plus equals C, remaining minus equals 100, and then below that, to account for the one less idea, below 100 is 90 this time, result plus equals, we want x, we want xc for that, and remaining minus equals 90. Let's do another run. Looks like we're up to the correct spot. We are now up to 500. This challenge is like a marathon, except my legs don't hurt as much. Not that I would really know from experience. Anyway, while remaining is greater than or equal to 500, result plus equals D, remaining minus equals 500. Let's test that. That's good. I'm going to keep on adding everything else. I will see you at the end of the rest of these specs. Welcome to the other side. I am glad you got here. It was a long and tumultuous journey. We have arrived here mostly in one piece. We got a good 60-something lines of code here. So just to walk through through the entire thing again, we can get rid of these comments here. We start with our result, declare our base case. Whenever I'm accumulating something, I always like to start declaring the base case. You pretty much have to. Then I've renamed num to remaining. And so we are starting with the largest one. So if we have something greater than 1,000, we will start concatenating m's. And we'll do that in multiples of 1,000 until we get to things less than that, say 999. Once that happens, we get passed down to our next statement. 999 in this case is greater than or equal to 900, so then we'll concatenate a cm, the late ancestor of m. That made no sense. Anyway, the code does, that's what matters. We concatenate that, we subtract 900, so in that case we'd be down to 99. It would skip a few more, but if we were in this range here, if it was greater than 500 and less than 900, that's essentially what this is all doing, these different loops and statements at these different times. It's checking for a range. It's checking for a range implicitly. Like what I just said here, it's checking to see if there's a number in between 900 and 500. Less than 900 but greater than 500 in order to concatenate these things here. I've seen a few solutions where people take variables of counts of m's and d's and c's, which is a really great idea. And when they do that, they are looping and they're checking, they're using an AND statement to check if something is greater than the larger number or less than the smaller number, and then adding those letters, which is a totally fine way of doing this as well. This takes care of it in a slightly different way, and it's a very repeatable way as well, which is why I like this for starting out. We keep going through this same idea again until the numbers get smaller and smaller and smaller until we eventually get down to the number 1, and then eventually to the number 0, upon which that time we will return the results. So if we run all of this, we'll see that we pass, that Pikachu chose us, and that we are so much closer to becoming the Pokemon Master that our parents always wanted us to be. If something here didn't make sense, please let me know in the comments, and I will make so much change out of it. And also, be sure to check out another example video that walks through this solution recursively, which is a load of fun for me, and hopefully it will be for you as well.